everyone! Welcome back. Today we are going to be doing some math together. We're going to be doing a number talk image, and I have with me here two mathematicians who are going to join us. Mr. Fluffy.
Hi everyone!
And Daffodil. Hi! So, Mr. Fluffy, Daffodil, you might think that you are the only mathematicians here, but you're not. We have more mathematicians watching from their computers.
Did the computer eat the children?
No! The computer didn't eat the children! But they are going to be participating with us, so they are watching from their homes. But even though they're in their homes, they are still mathematicians, and we're going to work our math muscles together. You ready?
Yes.
Daffodil, you ready? Uh-huh. All right, mathematicians, get your eyes ready. Get your ears ready to hear some strategies, and let's get started. So before we begin with our number talk, please make sure your video is in full screen. You can make it full screen by pressing the icon that looks like the one I have on my slide that's located in the corner of the video. Okay, so for our number talk today, we are going to be using our addition anchor chart. Our addition anchor chart I've attached to Parent Square, but we can also be following along using the one in our video. Let's get started. All right, mathematicians, how many do you see? How do you see it? You may choose to pause the video as you think of your strategy. How many do you see? How do you see it? First, let's hear Mr. Fluffy's strategy.
Well, first I saw 5. Then I saw another group of 5. Next I saw another group of 5. Then I saw another group of 5.
Thanks, Mr. Fluffy. So, mathematicians, did you see it the same way, or did you see it a different way? Let's help Mr. Fluffy find the total number of flowers. First, let's help him by writing an equation. How can we write an equation to match Mr. Fluffy's strategy? This will help us find the sum. So think, what is an equation that matches his thinking? Yes, 5 plus 5 plus 5 plus 5. Mr. Fluffy saw the groups of flowers in 4 groups of 5. Now we have to represent Mr. Fluffy's thinking. So let's look at our anchor chart and choose a mathematical model. Looking at our mathematical models, I'm wondering if we can show Mr. Fluffy's thinking on 10 frames. What do you notice? Now that we have represented Mr. Fluffy's strategy on a mathematical model, let's think of a strategy to help us solve his equation. What strategy can we use to solve this equation? Looking at our anchor chart, I'm looking at our different addition strategies. We have counting on, doubles plus or minus 1, and a make a 10 strategy. Which one would you choose? I'm curious to see how we can use a make a 10 strategy to help Mr. Fluffy solve his equation. So how can we use the make a 10 strategy? Yes, to make a 10, we can combine our different 10 frames and combine our numbers to make a group of 10. So we took 5 plus 5 and made 10, and then we took the other group of 5 plus 5 to make another group of 10. In mathematicians, we can now use one of our doubles facts. What is 10 plus 10? Yes, the sum of 10 plus 10 is 20. 10 plus 10 is the same as 20. So this is making me curious, though. Our original equation from Mr. Fluffy was 5 plus 5 plus 5 plus 5. we turn that into 10 plus 10. So true or false? 5 plus 5 plus 5 plus 5 is the same as 10 plus 10. True or false? Yeah, it's true. Why is it true? Think to yourself, why is this true? It's true because the sums of each equation are equal. 5 plus 5 plus 5 plus 5 is the same as 20, and 10 plus 10 is the same as 20. And we know that 20 is the same as 20. Thanks, Mr. Fluffy, for sharing your strategy. Let's hear from another mathematician. How many do you see? How do you see it? Oh, thanks, Daffodil, for volunteering to share your strategy. What did you do? First, I saw a group of 8. Then I counted 4 more. Okay, Daffodil, stop right there. Let's solve what Daffodil's done so far. Looking at our anchor chart, I'm curious if we could use the same model and strategy as we used before to help Daffodil solve 8 plus 4. What do you notice? Yes, one thing we can do by using a make a 10 strategy is first decompose the 4 into 2 plus 2. Notice how on the 10 frame, we can divide the 4 into 2 groups of 2. What are we going to do with one of the groups of 2? We can add the group of 2 up to the first 10 frame. Add it to the 8. What happens when we add 8 plus 2? Yeah, we made a 10. 8 plus 2 is the same as 10. But what about that other 2 that's left behind? Are we just going to leave it there? What can we do? Yes, we can add the 2 to our group of 10. So 10 plus 2 is the same as 12. So we've helped Daffodil count so far. She started with 8 plus 4, and we found that by adding them together, the sum is 12. What might Daffodil do next? Yeah, let's hear from her. First I saw a group of 8, then I counted 4 more, so now I have 12. Then I counted on 8 more. So Daffodil started with her group of 12, and then she counted on 8 more. Let's represent Daffodil's thinking on a model. Looking at our anchor chart, what model might we use? We already know we are using a counting on strategy because Daffodil said so when she was sharing her thinking. So I'm curious what counting on strategy would look like on a number line. Here's our number line. Where might you start? Should I start at 0 or 1? No, Daffodil said she's doing a counting on strategy. If I started at 0, I'd be doing a counting all, and that's not what she said she did. So how can we show counting on? Yes, we can start our we can start our counting at 12, a bigger addend than 1. What might Daffodil do next when she says she counted on 8 more? All right, let's count with Daffodil, making sure we're counting 8 jumps. All right, so we have 12, 13, 14, 15, 16, 17, 18, 19, 20. Will you double check for me to make sure we just counted 8 jumps? Yes. 12 plus 8 is the same as 20. So both Mr. Fluffy and Daffodil reached the sum of 20, but they did it in very, very different ways. Did you see it the same way as Mr. Fluffy? Did you solve it the same way as Daffodil? Or did you have your own strategy? Thank you for learning with us today. Mathematicians, thank you so much. I'm so excited to continue learning with you, even if it's through our computer.
What? Computer? Wait, so they didn't eat the children. The computer is not chomping on children. Munch, 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 munch.
No, Mr. Fluffy, no, no. The children are safe. They're learning on the computer. But the computer didn't eat the children. At least I hope not. Let me know if you've been eaten by a computer. Okay, that's it for me. Bye, mathematicians.